Surname. And finally, a number is not a valid variable name in JavaScript. It's okay if it doesn't start with a number, so if we add an S in front of it, for example, it would work, but let's rather do 1000 like this. Again, with the camel case. Now, let's see if this works. I'm gonna log out first name, surname, and 1000. And boom, read barter 1000. It worked. Great job on doing your first coding challenge. Now let's get back to the course.
Added code with strict modes.
Here we have a variable, which we've named message. It holds the text hello world, and it was created using the var keyword. So we've defined a variable exactly as we should. But what happens if we forget the var keyword and only provide the variable name, message? What's going to happen? If we run our code, we don't see an error. So apparently this code ran successfully, and therefore a value called message was created. But was it as a variable? In fact, it was added to something called the global object. The global object is something that can be accessed anywhere within our application, and this behavior can be very helpful. We're going to be working with the global object a great deal in this course and in our applications in general because it gives us a lot of useful features wherever we need them. And note that the global object is different across environments where JavaScript is run. So we're aware that we're running JavaScript in the browser right now. And for the browser, the global object is named window. And for JavaScript running on the server, such as with Node.js, it's called global. Now, to resolve these different names and just use a single reference to the global object, a brand new feature is being added to the language in 2020 that enables us to use the name global this to properly reference the global object across any environments, say either the browser or the server or whatever other environment JavaScript may be running in. So if our environment is a browser, you can refer to the global object with window. But note that in the future, if you're writing JavaScript in multiple environments, it's better to use global this instead. So here in the browser, we can actually see our global this. The global object. It was added to something called the global object. The global object is something that can be accessed anywhere within our application, and this behavior can be very helpful. We're going to be working with the global object a great deal in this course and in our applications in general because it gives us a lot of useful features wherever we need them. And note that the global object is different across environments where JavaScript is run. So we're aware that we're running JavaScript in the browser right now. And for the browser, the global object is named window. And for JavaScript running on the server, such as with Node.js, it's called global. Now, to resolve these different names and just use a single reference to the global object, a brand new feature is being added to the language in 2020 that enables us to use the name global this to properly reference the global object across any environments, say either the browser or the server or whatever other environment JavaScript may be running in. So if our environment is a browser, you can refer to the global object with window. But note that in the future, if you're writing JavaScript in multiple environments, it's better to use global this instead. So here in the browser, we can actually see our global object window if we just console log window. So when we run this, we see that we get window in our console. And to see that our message was put on the window, we can say window.message. And when we run this, what do you think we'll get?
Hello world.
We get the text message
But
that was set to
it's global.
hello world.
So we do.
And note that when working with the global object, we often don't have to reference it by name. So we can omit window entirely. We can just console log message. We still get message's value. So this is the important thing. If we forget the var keyword when creating a variable, even though we can access it like it's a variable, it's not one. it's a property of the global object. And this should be concerning to you as a JavaScript developer, because if we have access to values from the window without knowing it, what if there's a local variable with the same name? For example, we could have a valid variable named message that we declared underneath, maybe with the text, hello again. So with this code, how do you know which value you're using down here? The property of the global object window or the local variable? And the problems are even more apparent if we use a name that already exists on the global object. For example, let's just comment out what we've written so far. For example, a function that we can use throughout our program to display to other developers something is the console log function, which we've been using from the beginning. And we can pass this any message we like, for example, the text or the string hi. So we see that this works. And console, what we just used, is also a property of the window. We're just omitting the window reference here. So what if we were to incorrectly create a variable with the same name, console, set it equal to the string hi, and then afterwards try to correctly use console log the function? Think about what we've seen earlier with variables declared without var, and try to guess what will happen when our code runs here. Making
But
sure
it's
that I
going to
spell
be the window.
console correctly up here.
Windows dot.
We get a type error. Console log is not a function. Why? Because we overwrote the console property on the window object simply because we forgot var. So how can we fix this behavior? Well, first, let's take a step back and talk about how JavaScript is run. There are two ways or modes that JavaScript can be executed. One called sloppy mode and another called strict mode.
I haven't heard about this.
Sloppy mode, normal mode, is the default in scripts. So that's what we're running in right now. On the other hand, strict mode is a mode where several pitfalls of normal mode are removed and more errors are thrown. And this can be switched on in scripts, meaning we can change our script from sloppy mode to strict mode. So it throws more errors, prevents pitfalls of the language. So, as I mentioned, since we're in sloppy mode right now, let's try putting our code in strict mode. So let's uncomment our previous code, our example from the beginning, and to put our entire program in strict mode, we can switch on strict mode for a complete file by putting the following code on the first line. We use the string use strict, 2 words, written exactly like this. Now, if we try running our previous code in strict mode, when you try to use a variable
Guys, you can
that
activate
hasn't been
strict
created,
mode.
we get a reference error.
Oh, wait. Activate strict modes. He is heading to, and then we do add use strict modes. Use strict, right? And then commas, and we put it into something called code. Where is it? The type? Nope. Email type code. There we go. Use strict modes. Add this code at the beginning of the JavaScript, let's call it a JS file. Yep.
That stops the program and tells us that the variable we're trying to use, message, is not defined. And this is exactly the behavior we want. We want this error to stop our program to prevent changing or mutating the global object and potentially overwriting existing properties on it. There are a lot of things that useStrict does beyond this, and for such helpful errors, we want our JavaScript to run in strict mode whenever we can. So know that strict mode helps with variables and a lot more quirks of the language, but there are still some issues when working with var to be aware of, such as the problem of hoisting. So what is hoisting? Let's take a look at another example. Say we have a valid variable with the identifier age, and it's set initially to 26. So let's take a look at what this age variable contains by logging it to the console. And naturally we get the number 26.
Okay.
So it works like we would expect, but what if we tried to log age or access it before it was created? What's going to happen if we
throw you
do
an
so?
errors?
When we run this code, we don't get 26 and we don't get an error,
Okay.
but we get the empty value of a variable. So what's happening? Well, let's go back to the word
Because
that
you
I
haven't declared, so it's going to be no. I thought it's going to be throwing an errors we call undefined because the age is undefined. Let's throw a no, so nothing.
used to describe this particular situation, hoisting. Hoisting is the way that JavaScript developers describe the strange ability to access a variable before it's been created. When the JavaScript engine, the thing that runs our code, looks at our code, it's as if the variable's declaration, just the declaration itself, has been hoisted or lifted up to the top of the program, and nothing else, not the value the variable is being set to. So to rewrite our program in terms of what the JavaScript engine sees, it looks like this. We have our declaration, then our log, which logs the initial value of a variable, undefined, and then we're assigning the value of 26 to age. So only afterwards would we be able to get the correct value of age, 26. So in other words, hoisting describes the behavior of lifting up or hoisting a variable declaration to the top of the context it's running in. And this context is also known as its scope. And this is why we get the default empty value of the variable undefined when we console log it. And this doesn't make any sense to be able to use something before it's been created, so we would hope that this causes an error in strict mode, but we can see clearly that it doesn't. So if strict mode fixes some of the problems with var, but not all of them, including the problem of hoisting, what can we do? We'll cover that in the next video. In the last video, we saw some of the benefits of using strict mode, meaning changing our code from being in sloppy mode, which is the default in scripts, over to strict mode with the help of the string useStrict up at the top of our program. But we ran into a problem when it came to hoisting. We saw that we could access a variable before it was even declared or created. So this is an apparent problem in our code. So how do we fix this problem of hoisting in our applications? Well, fortunately, as compared to just using var, there are a couple more keywords that we can use to declare variables. And these are called let and const. And unlike var, variables that are declared with either let or const are not hoisted. They're not susceptible to this behavior. And we can prove this by replacing our previous examples with both let or const. We saw that since var declarations are hoisted, we can access variables before they're declared, but let's see if this code will run with a variable declared with let now. Let's see if we can do so with let.
I was wrong about this. I was thinking that var, yeah. So var would give you anything. Would give you a hoisting effect, in which, if you console log the variable before you declare it, it's going to give you a null, which like it brings the variable up, but without the value. So I don't think let is going to do the same thing as going to throw you an error straight away. Straight away is going to throw you an error. It's not going to do anything else. I'm assuming that's going to be how it's supposed to be.
When we run this, we get a reference error telling us you can't access age, you can't access a variable before it's been initialized, before it's been created, in other words. And now let's try this with const. And again, we get the same reference error. So indeed, neither let or const variables are hoisted.
All right.
They're going to stop our program dead in its tracks if we're trying to use something that hasn't been made yet. And note that there's actually a name for this behavior with let and const, how they prevent hoisting. So when you try to use a let or a const variable before it exists, the space between where you're trying to access the value and where the variable is actually created is what's known as the temporal dead zone. It's just a complicated sounding way of expressing what we already understand at this point, that let and const variables aren't hoisted, unlike var. You can't use a variable until it exists, and this dead zone refers to the variable being dead in this area, meaning it doesn't exist yet. It's not more complex than that. And since hoisting is no longer a thing with our new keywords, we're also going to get an error if we try to declare variables multiple times with the same name. We're going to get a syntax error telling us that variable has already been declared. It's already been created before. So at this point, we're kind of using let and const interchangeably to solve our problem. But why are there two keywords? When are we going to use let versus const? The simple rule is that when a value is going to change, we want to use let. Let is the best choice. And this is due to the behavior of let. Only let, as compared to const, can be declared and reassigned on separate values. In a sense, it works pretty similar to var. So for example, we can declare a variable with let and then initialize it, give it its initial value on a later line. And this is totally valid. And note that if we can initialize it once, like this, we can also reassign it. So this is valid too. However, if the variable is declared with const without initializing it, you're going to get an error. So if we run this, we're going to get a syntax error, missing initializer and const declaration. We need to give it a value, an initial value, when we declare it. So let's set it equal to 26. Now this is valid, and if we try to change it later on, we're also going to get an error. We get type error assignment to constant variable. So note that constant represents the value that const variables hold. They're constant, they don't change. So they need to be initialized when declared, and they also can't be reinitialized. But aside from these basic points and how both of these keywords fix a persistent problem with var variables, in the next video we're going to take a deeper dive and figure out where each of them should be used within our programs.
There's no challenge. Okay. Like some challenge. Temporary.
So it's time for a new coding challenge. This time we're testing your const and let skills. So it's actually 3 challenges this time. In the first one, I want to log out the name read, but it doesn't work. So can you fix it? In the second one, I want the number 102 to be logged out right here. But the thing is, we're getting an error. So try to fix that. And finally, I want you to log out the price of 50 I'm setting here, but it somehow doesn't work. So I need you to fix it. So go ahead and try to solve all 3 of these now. As always, check out the hint section if you get confused, or rewatch Reed's screencast. So go ahead and solve it right now, and then when you're done, I'm going to show you how I would do it.
All right, so first of all, what we have is a one lock out the read, but doesn't work since it's a const. So name missing initializer in const declaration. Const name read. Let me change to let, and let's see what happens. Run. Read. So since const here is going to be like no, and then you reassign the name to read, it's not going to work. So const count equal 100, it cannot be reassigned to 101 or 102, so we do let. Run it. 102. That's good. So const count is going to run this, and the last one, the last result. Let price. So we fix this. We put price up top before this, and we have it. Now we run. Okay. There we go. Boom. Boom.
Okay, let's have a look at how I would solve this. When you declare it, you can't declare it on one line and then initialize its value on another line. You have to do it in a single line. So by doing this, it should work. Yes, and it does. We're logging out on is that and yes, it indeed works. We're now logging out the count and then logging it out, read and let, which is a core skill set to have as you become a JavaScript developer. So let's continue on with the course.
So let's return to the question we asked at the end of the last video. What should you declare most of your variables with, let or const? In most cases, const is the best choice, not because it allows you to do the most with it, but because it allows you to do the least. And this may seem a bit strange and unintuitive at first, but we'll see the reasoning behind this statement in this video. Note that const has restrictions that let doesn't, and as a result, they make your code more readable.
Yep, so const, you just can't use it once. You can only declare a variable with a const, what is it called? Reserve word once. With the const, only once, and then you cannot reassign it to anything. That's why it works a lot better in certain case, certain situation. Most of the time you consider const before let. If it will be reassigned to something else, then we use let. And if it will going to stay the same throughout the course of your code, it's going to stay as const, right? So always think about const first. Can this variable use const? If it yes, then use it. If it cannot, it will change, then use let. Yeah, that's just how I see about const and let.
In general, const works just like that of let, but with two important differences. One, it must be initialized with a value.
Two. Why const? Const over let. Right, so we do this and we do const restriction makes code more readable. Reason number 1. Reason number 1. Right. Dot reason number 2 must be initialized.
And 2, that value cannot be reassigned after it's been declared. Attempting to modify a const variable is going to result in an error.
Reason number 3.
So both of these things we saw in the last video. Now let's revisit this age variable we've been using, and we'll declare it with const. So const age is equal to 26, like we had before. So let's say we give it an initial value, but we want to change it to 36 within our program. If we run this code, we see the error that we got before. We get a type error assignment to a constant variable.
All right, give me a moment.
And this behavior of throwing an error highlights the benefit of using const throughout our programs. Const is a great default choice for declaring your variables because it can't be reassigned. When you assign a value to a variable, you're not just declaring a piece of information, you're also declaring your intent within the program to yourself and to other people, meaning you're telling other developers what you plan to do with that information. When you create a variable and indicate that it shouldn't be changed by using the const keyword, you're telling others that they can, without even looking at the rest of your program, what follows this bit of code, that this variable is going to stay the same. The value stored in it is going to stay the same. And this is as compared to variables that are declared with let, and especially variables declared with var. Both types of variables declared with let or var, can be reassigned. And since they can be reassigned, they can be changed at any time, at any point within our program. So let's take a look at a specific program. We're actually going to look at 2 identical programs. And let's say we're running into an error, and we need to go through the code and look for an error, find that error that's popped up. And the way that these programs differ is in one important way. The first program uses const to assign variables, while the second uses var for its variables. So let me show you the code right now. So here's our first program. You can pause the video if you want to take a closer look at it and see what it does. I'll explain afterwards, but you can, for now, read through the lines and get a sense of what it does. This is our first
It's
program.
calculating 20% off.
And this is our second program. Now my question to you is, which one is easier to read, and as a result, find the bug in that we're looking for, and why? Take a minute and see if you can answer that based off of what you already know, as well as what you've observed in looking at these 2 programs.
So var original price is going to be 50. Sale price. Original price should be always be const. Percent off could be different. So it can be var, sale price, cons. It's cons, right? It's using the. Yeah,
So as we saw,
I feel like
both programs are identical, except for how the variables, these three variables, are declared. However, the first program, where the variables are declared with const, is much easier to understand. With the first program, you know exactly what's going to be logged, no matter what code after the variable declarations. And that is the calculated sale price. Sale price that's calculated here and put in the sale price variable. That's exactly what's going to get returned. And we know this because sale price is a const variable that can't be reassigned, can't be changed in any way before it reaches the end. With the second program, the variable is declared with var. You have no idea what the value of sale price is going to be at the end. You're going to need to go through all of the additional code looking for things like reassignments or conditionals or functions or anything that might in some way change
stretch. Right,
this
back
value.
to study.
Maybe our program has another discount applied to the sale price. Maybe there's a coupon code that's going to be added in the rest of our program that's going to discount the sale price even more. Maybe the sale is invalid. We don't know. Whatever the case, you don't know what the final value of sale price is going to be when it's assigned with var for that reason alone. When you assign a variable with const, it removes one additional piece of information that you need to retain in your head while reading the code. So let's go to our improved version of our app. But with this, let's make one small change to the first program. Let's declare sale price with let instead of const. Now with this, take a moment and think about what you can be certain of from this code. Well, now we can't be sure of the resulting sale price. The developers who have written this code, us in this case, have signaled that the original price, declared with a const variable, and %off cannot be changed. However, the sale price can. So by thinking about this code, we know what the right choice is for declaring most of our variables going forward, and that is const. We want to start with const because we don't want to signal to others that a value can be reassigned or changed when it shouldn't. And this helps guarantee that values are more predictable and not subject to unintended changes. And note that const works best with our basic data types, primitives, like we've been working with, numbers, strings, booleans. However, there's a vulnerability it has when it comes to working with non-primitive data types, namely objects. We'll cover that in time. So going forward, use const as your choice when declaring variables. And if
Why block scoping matters.
So now let's say we're building an e-commerce application where we're selling products to our users, and we want to display to our users whether our products are on sale or not. Sometimes we're going to have a sale for our products, so we want to take our product information, and for its given price, we want to discount it when we have a sale. So let's say we have a product with a given price, say 20, and we want to store this in a variable. So we'll create a var variable,
20.
and we'll give it the name price, logically. And we also want to track whether we're having a sale with another variable. For this variable, we'll give it the name isSale. And we'll track whether we're having a sale or not with the Boolean value false if we're not, or true if we are. So if we're having a sale, if isSale is true, and we can express this with a conditional statement, an if statement. If isSale is true, then we want to discount the price of the product. And in this case, let's say we're having a 10% off sale. we want to take 20, the original price, and subtract it by 2. And then within this if statement, let's say we needed to use our price again, we could put it in a new price variable, again with var, with the name price. And this variable is just going to live inside this if block. And then maybe afterwards we want to do something else with it. So let's check how things are working at the moment with a simple console log. So let's console log within the if block the sale price. Just include a string before the actual value to indicate that's what we're looking at. So first we have the sale price stored in this new price variable. But if we're not having a sale, we just want to console log the original price. So when we're not having a sale, when sale is false, the if condition is not going to be run, all that's going to be skipped, and we're just going to see the price. So if we run this, we get the default price value of 20, as we would expect. But if there is a sale, if sale is true, what do you think we're going to get? First, our if statement's going to run with our log, as well as the log after it, showing us the original price. What do you think we're going to get for each of these two values? When we run this, we see something a bit strange. We see that for the sale price,
Then
it's 18. That's good.
so it's basically run this block of code, print out sell price, and then the value is going to be 18. Right. And then is keep running. Since this is also true, this is run no matter what. So the price now is taking the price from here. Since this is true, is just push out this price is going to be 18 now. It's already reassigned, right? So it's going to be 18 as well.
So the correct discounted price, correct sale price is being calculated. However, for our second log, it looks like the original price stored in the first price variable that we declared, that's also being set to the sale price of 18. So what's happening is that the new price variable is not just living inside this if block, it also lives in the outside context too. Is affecting the value of this variable, which, as you might recall, the name of context in our JavaScript applications is called scope. In other words, variables declared with var that live in the global scope, or when we cover functions, they live in the scope of the function. In other words, var totally ignores this code block, the curly braces of the if statement. And as a result, the original price variable is changed to the sale price, instead of just creating a new variable here. See how problems might emerge if we wanted to. And as a result, the original price variable is...
So it's ignore this. Why?
In other words, variables declared with var that live in the global scope, or when we cover functions, they live in the scope of the function. In other words, var totally ignores this code block, the curly braces of the if statement. And as a result, the original price variable is changed to the sale price, instead of just creating a new variable here. See how problems might emerge if we wanted to use the original price value of 20 later on in our program. Say if we wanted to calculate a 20% off price, where we took the price and subtracted it by 4, we would get the wrong value of 14. So this poses some issues within our application. So how do we describe what's taking place here? This phenomenon of one variable overriding any variables of the same name that belong to a wider scope is called variable shadowing. The price variable that's declared in the if block shadows
that I need to
and overrides the other price variable. So since this is a problem, we want to figure out how to fix it. And the way to do so is to fall back on our previous solution of replacing var variables with let or const. And that's because an additional feature of let or const is that they are block scoped.
So var will work everywhere in the in the code, in the file, the global, and then constant let only works when you in a block. Not too sure about that.
And by that I mean any variable created within a block, such as the curly braces of this if statement, doesn't exist and cannot be accessed outside of the block. Any variables declared here are not going to exist out here in the outer scope. So now that we know this, let's replace the price variable that we're declaring within the block to a let variable. And let's see what happens. But first, what do you think is going to happen? Take a second and see if you can answer that.
This price was say at 20, and this one is going to be 18.
Well, when we run this code, we get the results that we originally wanted. We see that the sale price is discounted by 10%, it's 18, and the original price is kept at 20. So since the inner price variable is block scoped, it's scoped to this if statement, does not exist outside of it. Think of these curly braces.
Right, we do cons and let better than var. So we do h2, we do reason 1, cons and let work in a block scope premise. What is premise? Is it the right word? A previous statement, a proposition, which another inferent follow as conclusion. Yeah, true. That's true. While var work globally.
Braces now as gates that variables can't escape from. The two price variables that we have are in different scopes and are totally separate. In the block, the price variable is the sale price, is a completely different variable, and in the outer scope, in the global scope, the price variable is the original price. And as I mentioned, variables that are declared with const as well as with let are also block scoped. So if we just replace let with const here, we get the same correct result. Again, there are no conflicts. So just like the benefit of using const to indicate that it can't be reassigned, or variables can't be reassigned, the block scoping feature of let and const variables help us know our program better and indicate our intent better to other developers. Variables declared with let and const within blocks will only exist in that block. We don't have to worry about them conflicting with any variables in an outer scope.
Alright, template literals. Hey, let's delete this.
So now we've seen how to create
10 minutes, 17, 18. Yeah, we'll finish this topics by, yeah, let's do this afternoon. Let's do 3 of them. 3 of them more. Then that's going to take you around 4 hours. 3 and 45. Yeah, around 45 minutes. 3 hours and 45 minutes. That's pretty good hours. Pretty good. Yep. And yeah, so